In this video, we'll be creating our own backend framework in Python from scratch similar to FastAPI, Express, and Django. In fact, we'll be taking design inspiration from these frameworks and create something that's engineer friendly. We'll start off by learning how to handle routing of different HTTP methods like get, post, and delete. Next, we will add support for routing with slugs, enabling dynamic URLs that can capture specific values from the URL path. We will also implement route-specific middleware, allowing engineers to add custom processing or checks for individual routes. We will also include global middleware to apply common functionality that runs before all the routes in the application. We will then explore class-based routing, which helps organize engineers' code by grouping related routes together in classes. Finally, we will integrate a template engine, enabling your backend framework to render dynamic HTML pages. By the end of this video, you will have a basic backend framework whose features can be extended very easily. Subscribe because the button still lights up when I say it, and now let's get into the video. So let's get started by creating a project. What I'm going to do is go to the desktop and over here create my own folder. So for that, I'm going to use mkdir command followed by the name of the folder. So let's call the folder slow API. After that, I'm going to go to the slow API folder and open it in Visual Studio Code. After that, I'm going to close the welcome tab, open the integrated terminal in Visual Studio Code. If you don't have a integrated terminal in your preferred IDE, you can just use this terminal, but it's of no use to me, so I'm going to close it. After that, I'm going to create my own virtual environment in this project. Why? That's because if I use pip to install any package or dependency in this project, it will be globally installed on the system. And if I have another project using the same dependency, there can be a versioning issue. So let's say I install some package XYZ in this project. It uses version 18, but I've already installed it in the past for the previous project on my local system, which used version 14. Now between version 14 and version 18, there was a breaking change. So there's a versioning mismatch between the two projects. And because of that, I might face issues in the second project that I have. I don't want that. So what I do is create my own virtual environment for this project. What's going to happen is after I create a virtual environment, activate it and use pip to install any package in this project, it will stay within this project. It won't interfere with another project. It won't interfere with the global file system. So this way, the two projects are independent of each other because they're not dependent on one thing. So to create a virtual environment, I'll have to do Python or Python 3, whichever one you use. Then you can do -m venv. Now this part can be anything because it's the name of the folder of the virtual environment. After that, you can hit enter and we'll have a venv folder created for us. After that, we want to activate the virtual environment. To do that, we have to go to this venv folder. After that, go to the bin, and here we have the activate script that we want to run. So to do that, we are simply going to do source venv/bin/ and then we can hit enter. So this way the virtual environment is activated and you can see that over here the indication is given. Now the next thing I want to do is create a main.py file, and this is the main file where all of our application code is going to be. This is the main file. So now we can start writing our code, but before writing code we need to understand how we will even get started to create our own backend framework, and surprisingly it's very easy. It's very easy because of something known as WSGI. To understand WSGI, first we must understand what is WSGI. WSGI is short for Web Server Gateway Interface. So to understand WSGI, we must first understand what a web server does. Web server waits around for a request from any client. Once it gets the client, it takes this request and sends it to the Python app that we create. Now this Python app has to handle this request. And based on this request, it's going to return a response. Now, after the Python app returns a response, this web server is going to take this response and send it back to the client. So this is just what web servers do. It takes the request from the client, sends it to the Python app. It takes the response from the Python app and sends it to the client. You can think of web servers as the middlemen. All they do is serve clients. The web servers know nothing about content or anything present inside of those requests. All they do is pass information from one place to another. So how does a web server and WSGI, Web Server Gateway Interface, relate with each other? So back in the early days of internet, the web servers and the Python applications or any other application couldn't understand each other because they were speaking different languages. They were doing things their own way. They didn't communicate to each other properly. Because of this, the entire process was very chaotic. So that's when WSGI came into the picture. What WSGI did was similar to what a language translator would do. It would allow web servers and Python applications to speak the same language. So without WSGI, it would be like the web server and the Python application trying to speak different languages. But now with WSGI, they speak the same language, so they understand each other very properly. So what WSGI did in reality is just add a set of rules for a web server and a web application and how they should communicate. Now, if you read PEP 333, which is the document which specifies the details of WSGI, it will tell you how the application interface should be implemented so that you follow the WSGI guidelines. So if you scroll down, you'll find application or framework side, and here you'll notice that to create a simple backend framework that follows WSGI standard, all you need to do is create a function or a callable class which has two properties, environment and start response. This environment contains the details of the request, and start response is to send a response back to the user. So this is how easy it is to create our own backend framework. So what I can do is simply create def app which has two parameters. The first one is environment and the second one is start_response. After that, let's go ahead and print the environment variable to see what it contains. It's going to contain all the details related to a particular request. And after that, I also want to create a response body and send a response using the start response function. So I can simply pass in start response, and to this start response, the first thing we need to pass in is a 200 OK message. So that means the status code of this response is 200, that everything went OK. After that, we need to pass in the headers of the request. So I'm going to pass in headers equal to an empty list. After that, from this function, I will be returning the response. And the response is going to be a list where I pass in the response body. And what is the response body? It's going to be a string in a byte format. So to convert a string into a byte format, all we need to do is add b, and after that we can specify the response. Let's say hello world. After that, we can save the file, then we can open up our terminal and connect this application to a web server. Remember what I said? If the client is sending some sort of request, it's going to be sent through a web server, and we are going to provide this app to a web server. So I need to go to this particular file, catch this particular function of app and provide it to the web server. Now what is the web server we are going to use? The web server we are going to use is Gunicon. So first we need to install this Gunicon thing. So to do that, we're going to do pip or pip3 install Gunicon. And for me, it's saying no module named pip3 found. So we're going to do pip install Gunicon. And now it's successfully installed. Now to connect Gunicon to our web server, what we need to do is Gunicon, and then we need to specify the name of the file, colon, and the name of the function that we are going to pass in. So we are going to pass an app over here. So when we pass this function app, Gunicon automatically provides environment variable, the contents of the request, and start response function. That's why it has to be a function or a callable class. Callable class is something we're going to take a look at in the future, but for now, let's just focus on the function. This is how it is. Now I can click on enter. And you can see starting Gunicon 22.0.0, listening at this particular route, using worker sync, booting worker with PID 18035. So that means the Gunicon web server has started and it's listening at this particular port. So if I go to localhost 8000, let's go over there, we see hello world showing up. And now if I go back to the application, you'll see a big chunk of data being printed out, and all of this is this environment variable. As I said, this environment variable contains everything related to a particular request. So if you pass in any query parameter or you pass in any headers, it will be noticeable over here. If you see over here, it has request method, which is get, query string, raw URI, server protocol, HTTP host, all of that data. So this is how we've created a very simple backend framework by ourselves. Now, before moving forward, I would like to tell you that WSGI is not the only standard out there. There are multiple standards, and another more famous standards is ASGI, which stands for Asynchronous Gateway Interface. The difference between WSGI and ASGI, as the name suggests, is WSGI is synchronous, ASGI is asynchronous. That means if we use ASGI, we can handle multiple requests at once without blocking other requests. In WSGI, it can only handle one request at a time. If you know the backend framework FastAPI, that uses ASGI. And the web server it uses is Unicon. You might have seen that in FastAPI before. Just like we've installed Unicon, it installs Unicon. Now, we can make our application ASGI as well if we mix Unicon and Unicon, but we're not going to do that. We're going to create a very simple backend framework, and that's going to be slow API. That's why it's called slow, not fast, because it's WSGI, not ASGI. Anyway, coming back to the application, if we see, this is a very simple function. I want to do things much more difficult than what we already have. In our backend framework, we'll be able to specify if it's the GET request or the POST request or any other thing. And if we expand the app further, a simple function is not going to do it. It's not going to be very maintainable. So I'm going to remove this function, and instead I'm going to convert everything into a class. So we are going to create a callable class over here. So let's create a class called slowAPI, and then we're going to have an init method in it. So this gets called when we initialize slow API. So right now I'm just going to put in pass, which is a placeholder if you don't have anything else to put. And then I'm going to make the slow API a callable class. So to do this, you can just pass in __ call over here. And this call requires self, which is the first parameter in any function inside of a class. Then we are going to remove args and keywords, and instead we're just going to pass in environ and start_response. So again, just like we had in our app function, we're going to have environ and start response, because when we pass in the instance of slow API to the Unicon server, this function will be called. So now that we have this basic framework created, I want to do the exact same thing that we did before. We're going to pass in print environ, then we're going to have start response, then we need to pass in the status, which is 200 OK, and then we pass in the headers, which is equal to an empty list. After that, I'm going to return a list that contains a byte string which says hello, but with a comma in between. Now I can save it, and now I want to provide an instance of the slow API. What do I mean by that? I directly don't want to pass in slow API class. I want to create an instance of slow API like this. And then I'll pass in this slow API instance to the Unicon server. That's when this call is going to get called. When you initialize slow API like this, init will be called. But when you call instance of slow API like this, that's when call gets called. So that's what I want to do. I want to pass in the slow API instance. And right now it's giving us a warning because we have tried to instantiate slow API even before the class was created. So let's put it down and save the file. After that, I can close this web server so that I can restart it. So to close it, I'm just going to press Ctrl+C, and after that again run Unicon main app. But if you want to avoid rerunning the server every time you make a change, you can pass in -- reload to this Unicon. So it will reload every time the source file changes. And we're getting this error right now because I've passed in main : app. I don't want to do that. What I want to pass in is main slow API, right? I want to pass in this instance. There's nothing known as app in this file now. So we are going to the main file, and then we are providing the instance of the slow API. Now I can click on enter, and you see starting Unicon this, listening at this. And now if I restart the entire page, we see hello, world. And we also see the request details over here. That's great. Now let's say I decided to change the response that's coming across. So let's say I want to say hello Revan over here. I can save it and you see it automatically restarts the entire thing with the new changes. I can Command R and I see hello Revan on this page now. That's excellent. Now that we've created a basic structure of the application, we can get started with the juicy stuff. And before I get there, what I want to do is take this slow API and put it in example.py. Example.py is how our customers or our users are going to interact with our backend framework. So let's say FastAPI is created, right? It's uploaded to PyPy as a package. Now, when you install the package, you use it in a specific way, right? First, you create an instance of FastAPI, and then you can use that instance to create get post requests. We're going to do a similar thing. Example.py is how a user would interact with our backend server. So what I'm going to do is remove the instance of slow API from here, and instead, I'm going to go to the example.py and put slow API instance over here. Now, I'm going to press command full stop because I want to import the slow API class. So from main, we are going to import slow API. If we upload this to PyPy, how we are going to use the instance is just going to be import slow API or from slow API import slow API, whatever. But since we're doing this locally, we have to do from main import slow API. And if you're unfamiliar with PyPy, PyPy is just package index. Basically, it's npm for Python. It will allow you to see a list of Python packages that are present online. Now I can save this example.py, then I can open up my terminal, and instead of saying Gunicon main slow API, what I'm going to pass in is Gunicon example : slow API reload. After that, I can refresh my entire localhost and I still see hello Revan. That means everything's working fine. Now what do I want to do next? I want to add the capability of doing something like this. @slow API dot get, and here I mention the route that I want to create. Let's say I want to create /users, and then I create a function that says get underscore users, and this get users function is going to get a request and a response. After that, if I want to return a list of users, I can simply do something like a response.send, and then we pass in a list of users. Let's say something like this, where we pass in, let's say Revan, then let's say Naman, etc, etc, etc. So this is the thing that I want to create. Right now it won't work. So let's get started by seeing what components there are. First of all, I want to get something like get route over here, and it should be a decorator or an annotation. How do I create a decorator in Python? To do that, I'll go to the main.py and here start writing the code. So to create a decorator or an annotation, we'll start by creating a function, and this function is going to be get. Now this get is going to have a self as the first argument because we've created it inside of a class. Why have we created it inside of a class? That's because if we go to example.py, we're first creating an instance of slow API class and then calling the get function on it. That means this get function needs to be present inside of the class. It is not a global function. Now the second argument that we need to pass in get function is the path. So we require the path from the user, right? So we're going to have path equals none at the beginning. That means if the user has not mentioned any path, we set it to none. And inside of this get function, we are going to create another function, and this is going to be called wrapper. This is how you create an annotation. This wrapper is going to get a handler function, and then we need to do some logic. After that, we'll return this wrapper function, and this way we've created an annotation. That means I can use @slowAPI.get like this. If you want to check it out, we can do that. We can just go ahead and print handler, then we can save the file. And actually another thing I can print is the path. After that, we can save the file. Then we can open the terminal, run the Gunicon command again if it's not already running, and then it starts. Now I can go to my example.py file, uncomment these lines, save it, then I again have them, and as you can see, it prints out the function get users at 0x105, which is the hex code followed by /users, which is the path that we've passed in. So that means this get function is getting called as soon as the user does slow_api.get. That means the first part is successful. So what do we want to do if the user specifies a get route in their program? Well, if the user is just specifying the get route, we want to register it. We don't directly want to execute this get route, right? I mean, if you're writing your own backend framework, you don't want the backend framework to directly start executing whatever code is present over here. What you want to do is register this route. And by register, I mean save this route somewhere with all the essential information. That means we want to store the path. We want to store what type of method we are storing, because it can be a get route, post route, delete, whatever. Then we want to store this function that has been present over here. Why do we want to store the function? We want to store the function because we are going to execute it whenever the user's user, that means the person who's sending a GET request or the POST request, either through Thunder client or Postman or simply the browser. So how do we want to store this route? Well, I have a proposal for that. What we can do is something like this. We can create a dictionary, and in that dictionary, we're going to specify a route name. So in our case, it is users. And then we can again create a dictionary. In this dictionary, we're going to have the key as the get route. And then we can specify the function. Let's call it handler in our case. Why are we creating such a dictionary? That's because we can have get route, we can have post, we can have delete. So storing it this way essentially allows us to store different type of HTTP methods like get, post. It can help us support various methods in the future. That's why I'm inclined towards this structure. So let's store it this way. How do we do that? Well, we first of all have the path, right? It's users, but I want to do it a bit differently. What I want to do is go to example.py, and if the user has not already specified the path, let's say they just have slow_api.get, I want to extract the function name and use it as the route. So just to repeat myself, if the user doesn't have a path specified, we'll take the function name. And if they have it specified, we're going to take the path name. So what we can do is create a variable path_name, which is equal to path. So it will take the path variable if it is not null. And if it is null, then it will take handler dot __ name __. That means we'll get the function name. Now, if I try to print path name, save the file, it says /users. That's correct. But if I go to example.py, I remove /users, just save it like this. You see, we get users as the route name. But you see, in path, we have a /, and in handler.name, we have get users. We want to maintain consistency. We want both of them to begin with /. So I can just convert this to a string, put a curly bracket, convert it into an F string, and then put a /. This way, handler.name will always be preceded by /. Then we can save the file and I get /get users. Now having the path name figured out, what I want to do is store it in a dictionary like this. So if I want to create a dictionary like this, and the dictionary has to be persisted throughout the application, not just when a get route is called or a post route is called, we have to go to the init function and define a dictionary over there. So I can close the terminal, and here I can have self.routes is equal to dict. That means I'm creating a dictionary over here. Just to repeat myself, we are creating a routes dictionary at the top in the init function because we want this routes dictionary to be persisted throughout the program. That means as long as the slow API instance is present, this routes dictionary is going to be there. If I create it inside of this get function or this wrapper function, the routes dictionary will be rebuilt. That means it will be re-instantiated to an empty dictionary every time a get route is called. That means we cannot have a get route more than one time. Also, this routes dictionary won't be available in any other function if it's present in get function. So that's why we are creating it over here. Now to access this routes, we can simply do self.routes over here, and we get access to this dictionary. Now what I want to do is check if this path name already exists in the dictionary. If it already exists in the dictionary, that means we don't have to add this extra name. Or maybe if you want, you can override the existing function, but I don't want to do that. Instead, I'll give an error to the user. So I can simply check here if path name is not in self.routes, then we want to store this path name in self.routes. That means we want to store this path name key in the self.routes dictionary. So we are going to have self.routes at path name equal to an empty dictionary. So that means we have created a dictionary with a key and an empty dictionary as the value. Now inside of this, we can add the get route or the post route, whatever. So now what I'm going to do is self.routes at path name, and then I've already gotten access to this dictionary. Now in this dictionary, I'm going to store the get value as the handler. That means I'm overriding the already existing get route if it exists. So I can just do get over here, which is equal to handler. And this way I get a dictionary that looks like this. Now if I go ahead and print self.routes over here, then save the file, I come back over here, we see /get_users. Then we have a dictionary again where the get keyword is present followed by the function handler. And the beauty of this function handler is that if I want to call it ever again in my application, I can simply do self.routes at path name at get and then just put 2 parentheses after that. It will execute the handler function. Let's say I copy this function, I put it over here again, then I save the file. Let's call both the function routes as /users. Let me copy that as well and paste it. After that, we can save the file, come back over here and we see get function get users. First, it prints out 0x105117 and second, it prints out 0x105130. Why does it print it out 2 times? That's because every single time you call a get decorator, this function executes and it prints self.routes. So first time this gets printed and the second time this gets printed. So the final dictionary is the last dictionary. The value of get route is overridden. So if you want to allow that behavior in your backend framework, this code is fine. If you don't want to allow this, raise an exception. Anyways, now that we are done, we want to handle the actual calling of this get route. By that I mean if the user's user, that means the user accessing Thunder client or Postman, goes to the user's route, they should be seeing Rivan Naman. At this point what they'll be able to see is hello world, because we have not changed anything in the call function. Remember, this is a function that's getting called every single time user's user, that means the person accessing Postman or Thunder client, sends a request. That means if I go to Thunder client, so this is like a VS Code Postman, I click on new request, then I do http://localhost 8000/users, click on send, it says hello Rivan, because that's what I'd mentioned over here. And if I go to some other route that doesn't even exist, let's say even, then click on send, it still says hello Rivan. I don't want to allow that. Instead, what I want to do is if they land on a route that I don't have registered, I just say, hey, this route doesn't exist, 404 error. But if the route exists, like users, I want to call this function and execute it. So if the user has passed in response.send Rivan Naman, I want to send this list back over here as a response. So all of that is going to be mentioned in the call function over here. Let's get started with it. So I'm going to start off by just removing everything in this function. We know what all of this is, and then just put a pass. And now I'm also going to close the terminal and let's see what we want to do over here. So whenever the user goes to Thunder client, clicks on send, we first want to match if this route that the user has mentioned even matches one of our routes in the dictionary. In the routes dictionary specifically. Let's close the side panel and let's write the code for it. So what I'm going to do is run a for loop where we'll get the path and the handler dictionary. Handler dictionary means this thing that's present over here that contains the HTTP method and the handler function in self.routes. So we are looping over all the routes that are present in our application. After that, we need to loop over all the items that are present in this dictionary, right? As of now, there's only get route present, but there can be post, there can be delete, there can be patch, all other types of routes. So from here, I'll run another for loop, and that will be for request method, because first I'll be getting the request method followed by the handler function in handler dictionary. Now, if you want to make sure everything's correct, you can just go ahead and print path request method handler. Then open the terminal, go to localhost 8000, click on send, and it says too many values to unpack. And that's because I called self.routes. I want to call self.routes.items so that it gives me the key and the value both. If I just do self.routes, it's only going to give me the key. And the same goes for handler dictionary. I have to specify .items over here. After that, I can save the file, go to localhost 8000, click on send, and even now we are getting an error, but that's expected because we are not starting any response or anything like that. Here it expects us to send a response, but that's fine. The thing that we are concerned about is if we're getting the right things, and it is printing out the right things. If you notice over here, we have printed path, so we have /users, request method is get, and the function getUsers is also present, which is the handler. So that means everything's printing fine. Now over here inside of this nested for loop, I want to check if the path that the user has mentioned over here, which is even, and the path that we have over here matches, and also the request method matches. That means the request that's present over here matches the request that we have over here. If both of them are matching, that means we want to call the handler function. So here I can simply do if environ, because that's going to give us whatever the user has specified. If environment at request method, and that's what the environment calls it. If you want to open the terminal, scroll to where WSGI prints everything for us, you'll notice request underscore method over here. It's all in capital case, so we can put that as well. If environment at request method is equal to the request method that we have over here, and the path is equal to environ at, and let's see what its path is called. And if you see, path info is the string that tells us about the path that the user has mentioned. So I can just do path underscore info, and if both of them match, I want to call the handler function. So I can simply do handler, and now to the handler I need to pass in the request and the response. If you see over here, this was our handler, right? This is the function that we have stored. So if we call this function, for example, if you call getUsers function over here, what do you have to pass in? You have to pass in request and response, the two variables it requires. And similarly, we are going to do that over here. We have to pass in the request, which is environ, and then the response. And for the response, we'll have to create a new variable. So we can simply create response is equal to an empty dictionary, then pass that empty dictionary to the user. After that, we can start the response, and in this start response, we first have to pass in the status code. So let's assume the user edits this dictionary to pass in status code like this. After that, we need to pass in the headers, which we can assume again that the user has edited the response variable that we sent and have headers mentioned over there. After that, we can simply do return in a list form, response, and again we are going to assume that the user has specified a text over here. And now I'm going to wrap this with parentheses and call the encode function on it, because we want to convert it into a byte string, right? So encode will do that. Now I can save the file. I go to example.py. Here we have response.send. We cannot do that anymore because response doesn't allow any send method. We are soon going to have that, don't worry about it. That's actually the next step. But for now, let's just see how it comes along. What I'm going to do is edit the response status code. So let's have the status code as 200 OK. Then we are going to have the headers. So I'm going to pass in response at headers is equal to an empty list. And finally, we are going to have response at text. So I'm going to take this text value and set it as, let's say, again, Revan Naman. Then I can save this file. I can open the terminal. We still get this route registered. That's great. We go to Thunder client. We go to /users now, not even. Then we click on send. And it says list object has no attribute encode. And that's because we are passing in a list. Let's just convert this list into a string. Then we can save the file again, click on send, and it gives us Revan and Naman, exactly what we specified over here. To give you an understanding of how everything's working till now, let's understand it from the user perspective. What's happening over here? So the engineer has defined slow_api.get/users. That means a route is getting registered through this get function. After that, the user of this engineer, let's say, goes to some route and clicks on send. If they click on send, that means The Unicorn web server is going to take this low API call function and call this call function. And that time we create a response variable. Remember, we are creating a response variable inside of this call function because every response should be unique. It should start from scratch. You don't want to persist this response dictionary throughout the application. So after that, we loop over all the items in the routes. Then we loop over all the items in that dictionary. And then we check if the request method is equal to the request method that the user has specified and path is equal to the path info that the user has specified. After checking these two things, request method and path, we call the function that we had stored for a particular route. That means we're calling this function. And this function is exactly this function. So we need to pass in the request and the response. We are assuming that every user passes in request and response. If they don't, it will cause an error. So as soon as we call handler environment response, example.py function gets called. That means request and response variables are filled in, and then we change this response at status code to 200 OK. So we are basically modifying this response variable that's present over here, because remember, if dictionary is passed through a function, it's going to be call by reference, not call by value. In call by value, you create a new variable and pass it through the handler. But since we have a dictionary, it is call by reference. That means if you pass a response dictionary, it's going to edit that same dictionary. It's not going to create a copy. So this way, we modify the status code of the dictionary to 200 OK, headers is equal to an empty list, and text is equal to Revan and Naman, and we've passed it as a string. After that function is executed, we start the response, which is a variable given by the WSGI standard. So I start the response, then we need to pass in the status code. Hopefully the user has specified a status code. Then we pass in the headers. Hopefully the user has specified the headers. And then we return response.text.encode. So instead of statically mentioning everything, we have changed everything to dynamic values. That means it relies on the fact that the user has mentioned it. But here's the problem. We have not handled any edge case. All of this works in an ideal scenario. It doesn't work when the user has not specified headers, let's say, because that time it will give an error, right? If I save it, open the terminal, go to localhost 8000 users, click on send, 500 internal server, it says key error, headers is not mentioned. So you might say, hey, we can resolve that fact very easily. Instead of using square brackets, you can simply do .get headers. That means if the headers key is not present in this response dictionary, it will give none. It's not going to throw an error. And you're right, it will work. But the problem with this approach of using dictionary in general is that dictionary cannot have methods. I want to specify response.send instead of response at status code, response at text. So dictionary is just not suitable in this scenario. So to modify that, we can go to the Explorer, create a new file, and let's call this response.py. Here I'm going to create a class response, which is going to have an init function, and in the init function we are going to specify multiple things. First of all, let's see what the user can specify through the parameters. That means through the constructor of the response class. So they can specify status_code. They can also specify the status. So status code is strictly an integer. Status is whatever text you want after the status code, like missing, not found, or if you totally want to emit the status variable, you can do that as well. And that's exactly what I'm going to do. Then you can also specify the text. That means the text that you want to send across to the user. Arguably the most important part of your application. I want to send a list, Revan Naman. And that's all for now. After that, I'm going to initialize this variable. So I have self.status_code is equal to status_code. Then we have self.text is equal to text. Then we also have self.headers equal to an empty list. So if the user doesn't specify any headers or doesn't modify this headers variable, it is an empty list. Now I can take this class and instead of creating a response dictionary, I create response as a class. Then I'm going to press command full stop, which will allow me to add the from response import response line at the top. So we have imported the response class properly because we are going to the response file and importing the response class. Now, if we want to access the status code, we can simply do response dot status code. For headers, we can do response dot headers. Let me add the dot in between. And if you want to access the text, we can do response dot text. And now there's no need of this parenthesis. We can simply do response.text.encode. Nice. Now just doing this much is not enough. I want to go to the response class again and create a method inside of this class. And what is this method going to be? It's going to be the send function. So over here, if you go to the example.py, you notice I've commented out response.send. So in this send function, we can specify the status code, we can specify the text, and we can also specify the headers. So this decorator and this function thing was inspired by FastAPI, but this response.send and request response thing is inspired by Express, which is a Node.js library. So let's go to response.py again, and here we're going to have self, then we're also going to have the text, which is the first argument, then the status code, then we are going to have the headers. And if you want, you can not specify the headers over here. If the user wants to change the header, they can simply do response.headers is equal to something. They don't have to specify it in the send request. Then over here, I can simply do self.text is equal to text. So that means the text variable that we had as a response is equal to the text that we're getting from the parameter. Then we have self.statuscode is equal to status code. And that's all what send is going to do. Send is basically going to replace these two lines of code. And here we are just instantiating the values, right? Status code should be 200 OK, text should be Revan Naman. We can remove these two lines and instead say send Revan Naman, and then after that we can specify 200 OK. Now if we have done everything correctly, it should still work. So I go to localhost 8000 users, click on send. It says 500 internal server error. That's because response is missing two required positional arguments. And we get this error because if we go to main.py, we've called this class, but we have not specified status code and text. So we can specify it, or what we can do is go to response.py and set default values for them. That means in the beginning, we are going to set the status code to, let's say, 404, missing not found. And the text can be route not found. So that means if the user doesn't change the status code or the text, we're going to have 404 missing not found as status code, and the text will be route not found. Then we can save the file, go to main.py, or actually Thunder client again, click on send, and we get attribute error, list object has no attribute in code. So now there are two approaches to solve this problem. The first one is telling the user that, hey, we only have string type availability. So if you want to send a list, just convert it into a string like this and then send it. Then we'll get the right output. Or what you can tell is you can specify whatever you want. We'll handle it in the background. So in the response.py, we'll check if is instance text of string. That means everything's fine. We can have self.text equal to text. If it is of any other type other than string, we'll set self.text is equal to text and we'll convert it into a string. So that means if the user specifies a list, we convert it into a string. If the user specifies a dictionary, we convert it into a string. Now I can save this file, go to localhost 8000 users, click on send, and we still get the same output despite example.py having a list over here. And similarly, I can have a dictionary, I can have integer, whatever I want. Let's say I want to pass in 400. Click on send, we get 400. Now another thing that I want to do is take these two lines of code and extract them in the response function as well. So let me copy that, and I can come over here, create a new function. Let's call this as WSGI. That means we are converting it into a WSGI standard. We are going to have self, and then we are also going to receive start_response. Then we can paste these two lines in, and actually handler should not be mentioned over here. Handler should stay where it is. We only want start response. Then in the start response, we can specify the status as self.statuscode. We don't have to do self.response.statuscode. Then we can also do self.headers, and we're done. Then we can go to the main.py file. Here we can simply have response dot as WSGI. Then we need to pass in the start response function, and there we go. With this, everything works the same, but we have extracted this line in this function. The benefit of doing that is instead of doing a response.status code, you just do self.status code, which is present over here, and self.headers, which is present over here. If you want to specify more details to start a response, you can do that right over here. There's only one place where you have to control this as WSGI function. Now, a problem I have with this code is if I go to example.py, let's say I remove 200 OK. I'm just sending response.send 400. My application should be smart enough to figure out that, hey, if I'm sending 400 over here, maybe it is a right response. But when I click on send over here, we get 500 internal server error. That's because the status code is missing. So that means we'll have to add default values to the send function. So whenever the user sends a value, I'm assuming that the status code is always going to be 200 OK. So we'll override the already existing 404 missing not found to 200 OK if the user has a send function. Also, the text can be an empty string because maybe the user doesn't want to send anything. They just want to send a status code saying 202 or 204. 202 means that they've accepted the request, and 204 means that, yeah, everything went well, but I have nothing to say to you. So we can save this response.py file again. Let's go to Thunder Client, click on send, and we get 400 with status code 200 OK, even though I've not mentioned 200 OK over here. And maybe if we want to send a 404 response, we can do that by changing it over here. Then we can click on send again and it says 404 not found. So the status code is easily editable if you want through the send function, but hey, for our default values, we have specified 200 OK. So we are all set with the basic get function handling. That means the user can specify the route, and if they don't specify the route, we have get users, then we have validation for various stuff. We're giving back the request to the user. We're also giving back the response to the user, and using that response, they can send anything that they want. Now what I want to do is support multiple other request methods, not just get. So I can simply copy the function and paste it. Then we have post, we can again paste it, then we have delete, and thus we can support multiple things. But the logic over here is the same. It's going to be the same for every single function. So what I can do is extract this logic and put it in a function of its own. So I can simply create a function. Let me call this def route common because I'm really bad at naming things. Then we can have self, and we're going to require multiple arguments, but let's see what we require. First of all, we require the path of the user, then we require the handler, and we're also going to require the method name. Because over here, I've statically set method name to get, but it's not always going to be the case. It can also be post, it can also be delete. So we're going to take that from the parameters. And then we can pass in the method name over here. We can save the file, and if you want, you can remove this comment, but I really like it as a good reference. And then we can have, let's say, post, then handler 2, and maybe a delete at handler 3. Also, I can return the handler from this route common function. Not that it is going to do anything, but it's a good practice. Then we can return self.route common. Then I have to specify the path, which I'm getting from here. Then I need to specify the handler, which I'm getting from here. And then I need to specify the method name, which is get. Now I can copy this function, paste it again. Then we have def post, which is having path equal to none, handler, same thing, but instead of get, it's going to be post. Then I can again copy this, paste it again. Let's call this delete. Then we are going to have delete over here. That's it. So we have now supported two more types, post and delete. If you want to check it out, you can simply go to the example.py and have @slowapi. Let's say post /users def post users. Then we have request and response. Then we do response.send. And let's say we say, hey there, and then the value is 201. Then we can save it, open the terminal, then go to localhost 8000 users, click on send. I get the 404 not found and 400 response. After that, I'm going to click on post, click on send, and we get hey there 201 created. That means everything's working fine. Now the last change that I want to make for this simple routes is the user shouldn't always mention a string 404. Like if they're just specifying an integer, they can just do it like this, right? I can convert it to a string behind the scenes. It's a small usability thing I can do for them. So I can simply go to response.py, and after checking this instance for text, I can check the instance for the status code. If the status code is of the type of integer, then I can simply set self.statusCode equal to integer of status code, or actually string of status code. It's already an integer. And if it's not the case, then we're going to set status code equal to status code, whatever the value is. Then we can save it, go to example.py, let's convert this to 404, then click on send. It says 201 created for post, get is 404 not found. That's awesome. Now there are multiple more things you can do. For example, the user can specify a list over here, and that's obviously going to throw an error from Gunicon. We don't want to allow that as well. So here, maybe you can have an elif condition checking for the instance. Elif is instance status code of string. Then we want to set self.statusCode equal to status code. But if it's not an integer, not a string, it's an invalid value, so you raise an exception. So maybe you can raise something over here, and the error message can be status codes have to be either int or string. Then you can save the file, save example.py, click on localhost 8000 users, click on send. It raises an exception, status codes have to be either int or string. And it also says type error exceptions must derive from base exception, and that's because we have raised an error in the form of a string. It needs to derive from a base exception class, so maybe we can use value error, because if you go behind the scenes, value error extends exception, and if you see exception extends base exception. So we need to wrap it with some form of predefined or our customized class. I'm just going to use value error. That's because if you have a wrong value or a wrong type, you raise a value error. Then you click on save, go to localhost 8000 users, click on send. It says status codes have to be either int or string, and it's a value error. That's awesome. Everything looks good, and if you want, you can add more routes as per your choices. You know the drill. The advantage of moving this function as an abstracted function, that means a common function, is because we're going to edit this function a lot. And whenever we edit this function, that means whenever we edit the route registry function, or soon it's also going to handle the middleware registration, it easily reflects the changes in all of the functions. Otherwise, if we had everything inside of get, everything inside of post, and not an abstracted function, we would have to edit all of those functions again and again. So I hope that makes sense. And now we can go to example.py so that we don't get an error. And now we can start working on the next thing. The next thing is supporting dynamic routes. As of now, the user can only specify /users, but they cannot specify, let's say, a slug after it. That means if the user wants to go to user /1234, these set of rules will apply. But if the user goes to 4321, this set of options won't apply. There has to be a different route. I don't want to do that. I want to support the functionality that if the user lands on user 4321, same set of routes run. And if the user lands on 1234, same set of routes run. So essentially, we are supporting slugs if you're familiar with the concept. Or if you know any other backend framework, you might know they're denoted something like this. This is the syntax that's used in Express, I believe, and this is the notation that's used in FastAPI. That means the users followed by any other ID you want, and it will run these set of routes. They're the same routes, whatever ID you pass in. It's not going to be a set of different routes. So let's get to the dynamic routing part now. So the first step is obviously to get the slug out of the route. So to do that, we can implement our own algorithm, or we can use a package. So if you go to pypy.org, which is the Python package index, basically a repository that contains all the Python packages that are available. So we can search for parse over here. we find this 1.20.2 version, which we are going to install using pip install parse. And here are the specifications of how you can use this. Essentially, this is the opposite of format syntax. If you go at the top, parse is the opposite of format. When you use the format function with a string, you need to mention curly brackets in the string, and then in the format function, you'll specify the variables that should be put in instead of format. So to give you an example, if I want to print out Rivan is a boy and Rivan and boy are variables, I can simply put in curly brackets instead of them, and then I can call the format on them. Now I need to specify the args that should take place of this curly bracket. So I can pass in Rivan, let's assume it was a variable inputted by the user, and then we have boy as the second variable. If I try to print this, it will put Rivan instead of this curly bracket and boy instead of this curly bracket. Now parse is the opposite of this. In parse, if you notice over here, we need to specify two strings. And in one of the strings, we need to specify the curly bracket, which is basically our slug. And then in the second one, it's going to have the actual path. Let's see how we can implement this in code. And we're not going to do this in the route common function. And actually, even before going there, let me just install pip install parse. After that, we can again start running our application. Then we can go at the top and then import from parse, import parse. After that, in the call function, when we're doing for path handler dictionary and self.routes.items, I can just parse the route. So I'll simply pass in response is equal to parse. Then I need to pass in the normal format, which is path, because the user is going to specify something like this, right? They're going to specify users / let's say ID like this. We need to extract this ID then. So this is the format. If you notice, even in the example, the curly bracket part, which is the format, comes in the beginning, and the next part, which is the normal string, comes towards the end. So I can simply pass in path as the first argument, and the second will be again environ at path underscore info. Now let's try to print this response and see what we get. So let's print it out over here, and I'll open the terminal again. I'll also save the example.py file, then go to this users part, click on send. It doesn't find any route for it. And as you can see, the result is an empty object that time. And if I pass in 1234, then click on send, it has the ID 1234 in an object. Now if I remove this, click on send, again, this is none. And if I do it this way, /users, that means it's a totally different route. It's not /users /ID. So it's going to give us result empty object. So now first of all, we want to handle a case where the route doesn't even exist and the user's user, that means the person using Thunder client, is calling the route. So to handle that, we can simply do return response, which is this variable over here. And by default, remember, we have the status code as 404 and the text as route not found. So I'll just do response dot as WSGI and then pass in the start response variable. If I do this, it will send a 404 not found error if the route isn't matched. And this logic will still not work because we are returning response.wsgi, and in that function, we are just starting a response. We are not returning anything from here. So what I plan to do is take this return statement, return response.text.encode, and I'll push this into this as WSGI function as well. And then I can simply do self.text.encode. The benefit of doing this again is that whenever I call as WSGI, it will return this byte string, and all I need to do now is return response as WSGI. Even over here, I can just do that. I can click on save. Then I can open up the terminal. I'll go to localhost 8000 users, click on send. I get 404 missing not found. And if I change it to post, then click on send, I get hey there. So that's amazing. That means we're also handling the not found routes. That's perfect. The next thing I want to do is make use of this response. So if the user types in users123, click on send, I should be able to extract this ID and give it back to the user over here. So if they've mentioned ID over here, they should be getting an ID variable over here. So that's what I intend to do. I'll go to main.py now, close the terminal. I'll remove this print statement, no need, now I know what it does. And I also know the behavior of this response. So I can take this response variable and instead of saying path is equal to environment path info, I'll just say and response, or response is not none. Either of them should work. I'll just keep response over here. So that means if request method is equal to request method and response is not none, we want to run this block. Remember, response will give an empty object if path matches but there are no parameters, and it will give a dictionary if the path matches and there are params. It will give none only if the path doesn't match. So this way we can directly remove our logic that we had put over here, path is equal to environment path info, because if we put this, we are expecting that the path that the user specifies in the example.py should match the path that is mentioned over here by the user's user. And we do not want that, because if the user passes in 1, 2, 3, we don't want to separate it from 2, 3, 4. These are all slugs. They should go to the same route. So we're just doing and response over here. So if response is not none and the request method matches, we run this code. Now in the handler, we are passing in request and response. We also need to pass in the response over here, but not just like this. We need to pass in response.named because it will give us all the named objects inside of this path. And the user can have more than one slug, right? In example.py, they can have user's ID and maybe they want to have some other thing. They can have that. So we want to allow that. So that would mean if they have any other thing, let's say color over here, we also pass in the color for the user over here. So we just pass in response.named, and just passing in response.named like this would mean we are passing in a dictionary. We don't want to pass in a dictionary. We want to pass in separate arguments. So we convert it by putting in 2 asterisks before it. So we convert it into keyword arguments and send it across. This way, the user will be able to access it using the ID over here. And also, just to test, I'm going to pass in the ID as the response, then click on save. Even the main.py is saved. Now if I come back over here, click on send, it says 234 because I've mentioned 234 over here. And the status is still 404 not found because I've manually set it over here. Let me remove that, click on save, click on send over here, we get 234. Now I can pass in 1223234, click on send, and there we go. So that means the dynamic ID stuff is now working. Using the parse package simplified our life by a lot, because behind the scenes it will run its algorithm to find out all the matching parts in the route and give us access to them. That's pretty cool. Now the next thing I want to add is middleware. Our slow API backend framework is only going to support 2 types of middleware. The first middleware is the global middleware. In global middleware, the middleware runs once before all the routes are executed. That means even before the first route is executed, we run that middleware once. And the second one is local middlewares. That means for every route you can attach your own middleware and run it. So middleware only for a specific route. It won't get executed for any other route. So let's get started with that. First, we'll see how to handle the global middlewares, and then we can see how to handle the route-specific local middlewares. Now, how is the syntax of the global middleware going to look like? If you go to the example.py, we have the slow API instantiation. To this slow API instantiation, our users should be able to pass in middlewares is equal to an empty list, and in this list, they can pass in any sort of function they want. And this is the function that's going to be run before any of the route is executed. So you can have a list of middlewares passed to this. That's what we want. So here in the main.py, I'm going to create self.middlewares, which is equal to middlewares. And we're going to get this middlewares from the parameter of init. And if they don't mention it, it's going to be an empty list by default. After that, in the call, before we start executing any of the routes, we can loop over this middleware and execute all of the functions that are present inside of this, and make sure that this is a function. We cannot have any other thing. There cannot be an expression, there cannot be a variable, there has to be a function. So we can just do for middleware in self.middleware, then we check if is instance middleware, and we want to check if middleware is an instance of a function. That means this middleware is a function. So for that, we'll have to do types dot function type. And for that, we'll have to import types. So just do that. Here we have import types. This way, we're making sure that this middleware is a function. And if it is, we are going to call the middleware function and pass the environment, that is the request, back to it, because in the middleware you might want to do something with the request variable. There's not going to be any response variable, only the request variable, because request might be somewhere involved. Maybe you want to get the query parameter. All of that will be provided by environ, and that's all we need to do. So if it is an instance of function, we call the middleware, and if it's not, then maybe you can raise an exception saying that, hey, you can only pass in functions as middlewares. And maybe you want to wrap this with a value error or some other type of error. You can do that as well. Then you can save it, and here we have our global middleware. Now I'm going to go to example.py. Here let's create a function global underscore middleware. Then it's going to get the request. And then I can just say this was executed before any route. Then I can take this global middleware and pass it in the list of middlewares in the slow API instantiation. Now I can open up the terminal, go to localhost 8000/users, not users 1223234 whatever. Then click on send. It says route not found because it's a post request. Then I again click on send, and it says hey there. And as you can see, this was executed before any route prints 2 times, because first it fired up for a route that doesn't exist, and then it fired up for the route that exists. So here we have the global middleware concept done. Now let's work on the route specific middlewares. How is that going to work? Well, the user should be able to pass in a list of middlewares over here, and then it's going to work the exact same way. So I can just take this global middleware and I can pass it for the local route specific middleware as well. The only difference is that this middleware was present inside of slow API instantiation. For route specific, it's present inside the get or the post or the delete function. So to do that, we'll create another set of middleware, which is going to be called middleware for route. And then we can create a dictionary for this. Why is it a dictionary? Because we want to store it very similar to how we are storing the routes. Basically, the middleware is going to have a structure like this. It's going to have the route name followed by a dictionary. Then there's going to be get, post, the request method type, followed by a list of middleware specified for that particular route. Instead of function, we'll be storing a list of functions, and those functions are middlewares. So very similar structure to the routes that we've already done, but this time instead of storing one variable, we'll be storing a list, and it can have 0 to infinite middlewares or 0 to infinite functions. So I can just take this from here and paste it after we have done self.routes, path name method name is equal to handler. So this is for our middleware. And now I can do a similar thing as here. I can check if path name is not in self.middleware for routes, then self.middleware for routes at path name is equal to an empty dictionary. After that, we can do self.middleware for routes at path name at method name is equal to middlewares. And we're going to get that middlewares from the parameter over here. So we have middlewares passed over here. Now I need to pass the middlewares from where the route common is being called. So that means I need to go to the get request and here pass in the middlewares. And then I need to accept it from the function parameter of get. And this way we're done. Now I need to do a similar structure for post and delete as well. So I have middlewares is equal to an empty list. Then we have delete. Middlewares is equal to an empty list. Then I pass in the middlewares to the route common function. And similarly, I do that for delete as well. So this way we have taken middlewares from the get function or the post function or the delete function, and then I'm passing it to the route common function. Now that route common function takes in the middleware and sets it to a variable. Now I can go to example.py. Here I can create a new function. Let's call this local middleware. We get a request. Then I can print, hey, this was called here. Then I can take this local middleware and pass it to this function. I don't think anything is going to happen, and that's exactly what we want, because in the call, we have not added anything related to the middleware for routes part. we've only added for the global middleware, not for the local middleware. But that's what I want to check if our application is getting confused between the both things or not. So I'll click on send. We get an error, connection refused, and that's because I stopped running it. So let's click on send again and it says, hey there, 201 created. And as you can see, we get this was executed before any route and no other thing gets executed. Now let's get started with middleware for routes dictionary. We want to call that before the specific route gets called. So here when we have if environment request method is equal to request method and result, that means we have validated that this is the route that we want to call. We can just add our route specific middlewares because our middleware is going to run before any response is returned. So let's go ahead and access a specific middleware for this specific route. So let me create a variable route middleware list, which is equal to self.middlewares for specific routes at path, because that's how we are storing it, right? If you go down, you'll notice we have path. After that path, we get a dictionary. In that dictionary, we want to access a specific method name and then we'll get access to the list. So here at request method, and there we have a route middleware list. Now I want to loop over every single one of the functions in this route middleware list and call them. So we have for middleware in route middleware list. Then we are going to again check if it is an instance of the function. So we have middleware of the type of function type. And if it is true, then I want to call middleware function passing in request or environment to it. And if that's not the case, we are going to raise a value error saying you can only pass functions as middlewares. And there we are done with route specific middlewares. As easy as it gets. Very similar to this middleware and the route stuff that we did earlier. Now we can go to localhost 8000 users, click on send, we get an error, key error post. Why? That's because if you go to main.py, I've passed in a string over here for method name instead of passing in the variable method name. That's a small error. We can fix that. Then we can come back to this post request, click on send, and we get 201 created, hey there. Then we get this was executed before any route and no middleware gets printed because in our example.py, there's no middleware for /users. That's good. Now, if I add /user /1234, click on get, then click on send, it says 1234 and I get this was executed before any route and hey, this was called here. That means it is a route specific middleware that's running. So that's great. So with this, we are done with the middleware feature. The next feature that we want to work on is the class-based routing. By class-based routing, I mean we'll be able to create a class, let's say a class like this. Let's call this user. And at the top of it, we'll be able to pass an @slowapi.route. We can't use any other thing, just route. And here, if you want to change the route name, you can change that. Let's call this users. And in this class, you can specify a bunch of methods like def get, where you'll get request and response. And then you can handle the get HTTP request method for this /users route. And similarly, you can create post, delete, whatever. And also, if you want, you can have the ability to store variables inside of this and basically create a more organized version for your routing system. So let's see how we can implement that. First, we'll have to start off by creating this route decorator. Let's do that. So let's go to the main.py file and create a route. So we are going to have def route over here. We're going to receive self, path is equal to none, and we're also going to add support for middlewares for this class-based routing. After that, we're going to create our wrapper inner function, which is going to have handler. And now here we need to decide the logic we need to put in. Essentially, we are getting a class over here. Or at least we are expecting a class. So let's verify first that we are getting a class. This handler should be a class. So we can just do if is instance handler of what? How do I see if it's a class? Well, I just need to put in type over here. If I put in type, it ensures that we are passing in a class. Now, if that is the case, I want to do something. Otherwise, I want to again raise an exception. And this exception can again be just a string, or if you want value error. And what I'm going to type here is @route can only be used for classes. Then I can save this and we have the route created. If I open the terminal, run Unicorn, we get an error, and that error exists because we have not returned the wrapper in our function from here. So let me return that. We are returning a function, and now I can run it and it runs properly. Now what do I want to do over here if it is a class? I want to get all the functions that are present inside of the class, but I don't want to get literally all of the functions. I want to get the functions that the user defined. How do I know if it's the one user has defined? Well, for that, we can examine this class. We have underscore underscore init, which is a built-in method. That's not what a user is doing, and we don't really care about it. All we care about is this function get, or if there's post, or if there's delete function, we care about those. So I'll get access to these functions inside of a class. I'll filter out all of these underscore underscore functions because those are built-in functions, and then we can decide what to do next. After that, the process should be fairly easy. So we can go to the main.py again, and let's see how we can filter stuff out. To filter out, we use something known as inspect. So if you press command full stop over here, you can import inspect. It's given by Python itself. On this inspect, I can call the getMembers function, and then I can pass in an object. This object is going to be handler because I want to get all the members of this handler, and I can save that in the class members variable. After that, let me go ahead and print class members. Then I can save this. If I open the terminal, I see class, class type, delete attribute, dictionary. All of these functions are defined inside of this class. You might say that, hey, I didn't define all of these things, but they are present by default as soon as you create a class. So essentially, we want to get rid of all the underscore underscore methods. All I need is this get function over here, which is the one I've defined. So if I go to the main.py file, on this get members, I can specify a filtering part. If you hover over it, it says predicate. In this, I can pass in an anonymous function. An anonymous function is basically a function with no name. So I can just create lambda, which is the way to create an anonymous function in Python. It gives us a variable x, and what I want to do is check if this x is a function. If it is a function, then it's right. I want the class members to be a function because class members can also be variables or the data types that we create, right? Now you might ask, what is this x? This x is basically all the functions or all the members that we're getting from this get members. So it is all of these methods over here. You can think of it as we're looping over each of them and we get access to a particular class member. Now with this class member, what I want to do is first check if it is a function. If it is a function, then I want to check if it starts with double underscore and ends with double underscore. If it starts with and ends with double underscore, that means we want to ignore it. So all I'll do is inspect.isFunction. This way we can check if it is a function or not. If you want, you can just do isInstance x, then comma types dot function type, something that we have done before. But here I can just do isFunction x. Then I also want to check if it is not. So I want to return true over here only if I want a particular member to be inside of this class members. And if it is a function, and if it is not starting with double underscore and not ending with double underscore, I want it to pass. I want it to be inside of class members. So here I can just say and not inspect x dot underscore underscore name underscore underscore. You remember this? If it is a function, we can get its name like this. Then we can check if it starts with double underscore and it also ends with double underscore. So I can just do name dot ends with double underscore. And this way I have my class members printed out. If I open the terminal, I only get the get function. That's perfect. Exactly what I want. If I go ahead and create, let's say another one, let's call this post, click on save, I get and post, both of them. But here's the problem. What if the user specifies something other than get, post, delete, whatever our supported request methods are? Maybe they specify hello over here. It is a helper function, let's say. This helper function helps in get request or post request to fetch data from some database, let's say. So we don't want to include this in our functions, right? We don't want hello to be present. This is a helper function. They can keep it to themselves. So to ignore such a type, we can just check if the members that we have are present in supported request methods set. So I can go at the top over here, I can create supported underscore request underscore methods, which is equal to a set. And this set lists out all the supported methods like get, post, and delete. If you add any other HTTP request method over here, you can update it in the set. Why are we using a set, not a dictionary? Because if we want to look into a set, we want to check if a certain value exists in a set, it is more time efficient. It's O of 1. If we use a list, it can be O of n, and n is the number of methods you have. Now, it's not going to make a difference if you use either of them because we have a very limited number. So let's take the supported request methods and add it as another condition in this lambda function. We can just add x dot underscore underscore name underscore underscore dot upper, because we want everything to be an uppercase. Everything over here is an uppercase, right? So we want this function name to also be uppercase in supported request methods. Now I can save this file, open the terminal, and I see get and post only showing up. It doesn't show up the hello function. It ignores it. So again, just to revise, we have inspect is function. So first we are checking if it's a function. Then we are checking if it's not starting with underscore and it's not ending with underscore. And then ensuring that the function name is in supported request methods. Now that all of our validation is done, the next thing I want to do is store this route just like we do in post or delete or get. We call this self.route common, right? So for this, I'll have to loop over every member of class member and call route common for those things. So let's go ahead and do that. We're going to have for function name, comma, function handler, because that's what we're getting. If you open the terminal, we get function name and function handler. So I'll be getting for function name, function handler in class members. Then for each one of them, I want to call self.route underscore common, and then I need to pass in the path. Path will be path, that means the path that's mentioned over here, or the handler dot underscore underscore name underscore underscore. Remember, handler is the class, not the function handler over here, because this function is always going to be get, post, delete, whatever. It's not going to be anything other than that by the time we reach this part of code. And the route is going to be whatever is mentioned over here or whatever is the name of this class. So remember that. And we also remember that handler.name is not going to begin with slash. So let me add that using fstring. Once we have that done, let's see what we need to put in next. Handler. That's going to be function handler, because I want to handle this function based on what's present in my function over here. After that, we need to pass in the method name. The method name is the function name. It's either going to be get, delete, post, whatever. So that's the function name. And if you want, you can also put upper over here so that the function name, the get, is now capitalized. After that, we need to pass in middlewares, if any, and we directly get that from middlewares over here. Now it is true that we are not allowing the user to pass in a middleware for a specific get route or a specific post route, but you can work on that after you've completed this tutorial. It should be fairly easy because we have already got many of the logic points in place for it. So anyways, we have self.route common done here. And remember, we are not returning self.route common here just like we did over here. And the reason for that is if I return it over here, we are in a loop. So after running it the first time, the second route won't get executed. So that's why we need to do self.route common over here, not return self.route common. After that's done, let's restart the server. Let's pass in response.send. And then we can just say, hello, I am here. And the status code can be 200. Okay, I'm going to comment this line out. Then again, open the terminal, go to localhost 8000 users. 1234 should give 1234. That's fine. Now let's go to the class-based routing. I'm going to do get. It gives us, hello, I am here. That's nice. If I do post, it shouldn't give us anything. It gives us route not found. And if I pass in response.send there, and let's say the status code is 500, click on save, go to localhost 8000 users, click on send, I get there with 500 internal server error showing up. That means everything's working fine and we have class-based routing in place. If you want to check for middleware, you can do it over here. But it should work the exact same way as before because we really haven't changed any logic other than just adding a new decorator route. Then we've called the similar route common function and it does all of the tasks for us. That's great. Another thing I want to test here is if I remove everything inside of this route, it should take this class name. So if I save it, go to localhost 8000/users, it should give me route not found. And if I do user, it should give me there. That's perfect. If I do get, it should give me hello, I'm here again. That's nice. Everything seems to be working fine. The next thing I want to do is instead of giving the user a request dictionary like environment, I would like to give them a class. This class will allow you to access variables like this environment dot, let's say, path info. They don't have to spell it out like this. This is very non-user friendly. And also, if you notice, if I go ahead and print the environment variable over here, open the terminal, let's say I click on send, we get these things. The thing I want you to look at is the query string. It is an empty string as of now, and that's right. But if I do id is equal to 123, it will give me id is equal to 123 as the query string over here. That's perfect. That's exactly what we want. And Gunicon is doing its job. That's right. But what I want to do is extract this query string and convert it into a list. So we should have id 123 in a list of dictionary. And let's say if we have other queries, let's say name is equal to Revan, then click on send. I want a list having a dictionary with key as the ID and value as 123. I also want name as the key in another dictionary in that list and value as Revan. So instead of giving the user query string like this, we make it a bit nicer for them to use this request thing. So to do that, we are going to start off by creating a new class. So if I go to the Explorer and create request.py, here create a class request. Then we have the underscore init function. From here, we are only going to receive the environment variable. Then what I want to do is extract all of the elements of this environment dictionary and put it as an attribute of this request class. Now there can be so many hundreds or thousands of lines. I cannot manually just type them in, right? So we're going to do this dynamically using code. We're going to do for key comma value in environment.items. That means we get the key and the value of the environment dictionary. Then we're going to call the set attribute function that's present in Python. Set attribute function requires the object. That means what object do you want to set attribute for? I want to do it for this class itself. So we have self. Then we need to pass in the name of the attribute. So we're going to do key. But just doing key is not enough, because if you notice, some keys are WSGI.input. That's not a right attribute. So what I would like to do is key.replace, and I'll replace all full stops with underscore. So if you want to access WSGI.input, you do WSGI_input. That's great. Also, I will lower this so that everything is accessible using small lowercase HTTP connection. After that, I need to set the value, and value is going to be the same thing that's mentioned over here. I'm not going to edit anything in that. Now with this, I should be able to access each of the methods very simply. Instead of using square brackets, I'll use dot, and instead of specifying everything in uppercase, I'll do it in lowercase. But the main reason I created this class is because I want to create a queries variable over here. I want to remove this query underscore string and replace it with queries list. So what I'm going to do here is self.queries is equal to default dict. What is default dict? Default dict comes from the collections library. Essentially, any new key you create is assumed to have a default value by itself. So we don't have to do if this key is not present in a particular dictionary, we're going to have this as the value. No, we don't have to do that with default dict. It assumes that if the key is not present, it has a particular value. Now I'm just going to have if self.query underscore string, because now what I've done is set attribute for this request class. So that means the self now has query underscore string parameter. Earlier, I would have to do environment query underscore string, but that's not required anymore. We can just do self.query string. If self.query string is not null and if it is not empty, then I want to get the values. And what is the value? You can see it over here. Let's copy it and paste it as a comment at the top for our own reference. So what I want to do is split the string up by ampersand. Once I do that, I'll get ID is equal to 123, name is equal to Revan. Then I can split that by equal to, so I get the key and the value to put in this queries list or this queries dictionary. So we're going to have self.query string dot split, and we're going to split it by ampersand. Then we'll store that in the variable request queries is equal to that. After it, we can do for query in request queries because there can be multiple, right? There's not one, there's not two, there can be 3, 4, 5, 6, 7, whatever. From that query, I want to get access to the key and the value. So I can simply do query underscore key, comma query underscore value is equal to query dot split, and we're going to split it by equal to sign. So first we split it by ampersand, so these are two different things now. Then we split it by equal to, so we have ID 123, and for the second one we have name and Revan. Now all I need to do is self.queries at query key is equal to the query value. So my bad, whenever I said we're going to use a list of queries, no, we're just going to have a default dictionary. It's going to be a dictionary that looks like this. Oh, the ID 123 is present, name Revan is present. That's how it's going to look like. These are all of our queries for a particular request. Keep that in mind. It's not for all the requests, just a particular request. Now I can just go to the main.py file, and when I create a response variable, I can also create a request variable. Then I can import request from request, which is request.py file. Don't import it from url-lib. Then we can remove this print of environment. Now what I want to do is whenever I use environment at path info, I'll just pass in request. So here we have request.path underscore info. Let's remove the square brackets. Similarly, we have request method. Then we can look for something else. Let's say we have environment over here. We can pass in request over here. Then I can do the same thing for handler. And I guess we are done, but I would like to ensure that I've done it correctly. So I'll press Command F and see if there's any instance of environment other than this. And that's right, there's not. But I want one because I need to pass it to the request variable. It requires environment, so I'll do that. Then I can save the file, open up the terminal. Everything looks good till now. Let's test it. Let's click on send. I get hello, I'm here. This was executed before any route. And what I like to do is go to example.py. Then over here, let's go ahead and print request.queries. Let's save this. Click on send. I get default dict none with ID 123, name Revan. That's perfect. The request class is also working fine now. So we are almost done with the application, and the last feature that I want to work on is the template engine feature. So let's get started with that. What is a template engine? A template engine is a tool that uses a template to convert input data into an output document like HTML. For example, we'll have a template file written in HTML, and it has a structure like this: hello, followed by, in our case, it's going to have two curly brackets, followed by some name, which is the variable name, followed by two curly brackets. Now, in your programming language, you can specify the name for this particular template file, and then when it goes through the template engine, you have an output of hello Fred. So essentially, we want to replace all the curly brackets with the variable name present inside of it with whatever data the user mentions. So we want this ability. How are we going to do that? For that, we're not going to touch main.py, example.py, or anything like that. We're directly going to go to the response, and here we have a function called send, right? We're going to have a similar function, but it's going to be called render. So let's create a function called render. And in this render, we are going to have self, but we're also going to ask for the template name. So whenever the user calls the render method, they need to specify the template file name. and they can simply mention the template file name as XYZ, and we'll automatically add .html to the end of it. And we'll assume that they're talking about the current working directory. Then we can also ask for the context, if any, and by default, we are only going to have an empty dictionary. We'll understand what context means in just a bit, but first, let's just try to open this template file first. So for that, we're going to create a path which is equal to an f string, and then we're going to pass in the template name followed by .html at the end. Now we're going to have to open our path. To do that, we can simply open it using context manager. So we have with open, then we pass in the path, and we're going to open this in read format. By default, it is in the read format, and we'll open this as file pointer. After that, we can get access to the template using fp.read. So this gives us access to the entire file content. Then what I want to do is go over all the elements that are present inside of context and substitute it instead of the 2 curly brackets that we have. To give you a perspective, let me just create a file. Let's call this example.html. Then I can paste some HTML. It's a very simple HTML file with doc type HTML. HTML language is equal to English. Then we have a head document with title and 2 meta tags. Even if you don't put it, it's fine. Then we have a body tag with h1 hello name followed by p and then a p of message. So we have 2 things that we need to substitute, the name and the message. So context is going to take this name and the message, and then it will fill it in automatically. So context is essentially going to have our items, the main items that we want. So we want to loop over it and get those items. So we have for key comma value in context dot items. If you've not already guessed it, key is going to be the name and the value is going to be the actual value that we want to substitute in. So now what I'm going to do is whenever in this entire template I see 2 curly bracket, I want to get the content of this particular variable and replace it with the variable that's mentioned inside of context.items. So for that, I'm going to write regex. In Python, if you want to write regex or regular expressions that make this stuff easier, we can simply do template is equal to re, and then we'll import re. Make sure you do it at the top. Then we can do dot sub. That means whenever we see a particular pattern, we want to substitute something based on that pattern. So here I'm going to pass in a regex string, which is going to be like this. So first I want to check if it's beginning with 2 curly brackets. So I'll put in 2 curly brackets, and VS Code by default added the ending 2 brackets. We don't want that as of now, just 2 curly brackets that open up. After that, I want to ensure that if there is any space, we ignore all of the spaces and directly get to the variable. So we'll put \s asterisk, which will do that job. Then we can do plus re.escape. Then we again need to pass in a pattern. re.escape, as the description suggests over here, escapes special characters in a string. So what we want to escape is the key. So if it sees this name key, it wants to escape this. And then we can add plus r, and then we can have a similar thing but in a reverse format. We'll have \s asterisk and 2 curly brackets. So this way we're making sure that if there's any other spaces, it gets captured followed by 2 curly brackets. So if there's any space, it gets captured followed by 2 curly brackets. Then I need to pass in the replacement value. For that, we'll pass in string values so that whatever value we get, we convert it to a string. And then finally, we need to pass in the string. What is the string? The string is the template string in which the replacement should occur. So we'll just pass in the template over here. So with this, we are all done with the rendering part. All we need to do now is add a header. So we'll have self.headers.append, and here we'll append content type to be text HTML. Then we also want to change the text, so that self.text is going to be template. Then we are going to set the status code equal to, let's say, 200 OK. Then we're all done. Now if you want, you can take the status code from the parameters over here. You can also take headers from the parameter and add content type over here, but that's all good. You can already change the headers if you want by doing response.headers equal to something. That's good. Now let's try to use this render. What I'm going to do is go to the example.py file, and here whenever the user does post, I'm going to say response.render. Now in this, if you notice, we need to pass in the template name. For me, the template is example, and then we need to pass in the context. The context is going to be name, which is going to equal to, let's say, Rivan, and the other thing we need to pass in is a message. So we have message equal to hello there. Then we're all done. We can save it. Then our terminal is running, so we can go to Thunder Client, then click on post, click on send. We get an HTML file with hello Rivan, welcome to our website, we're glad to see you here, hello there. So it automatically does all of the conversion for us. That's awesome. Now what I'd like to do is go again to response.py and ensure that you understand this part correctly, especially this regex line. So what we're doing is creating an HTML path file, then we're opening that file, reading that file, and now we're going through all of the items in context. So context is a dictionary which specifies a key and a value. The key is going to be whatever is mentioned over here in 2 curly brackets, and the value is going to be whatever you want to replace this name with. Then to replace it, what you do is use RE module. RE module is the support for regular expressions in Python. Then you call the sub, which is a function in Python used to replace occurrences of a pattern in a string. And then you have this particular regex. What is this regex doing? This matches the opening double curly braces followed by any amount of white space. So we have 2 curly brackets followed by S asterisk, which means any amount of white space. Then we escape a particular key. If it escapes these special characters, they are treated as literal characters in the pattern. Then we are doing a similar thing here, just like this one, but instead of having double curly braces in the beginning, you have double curly brackets at the end. When you combine all of these things, it matches with something like this: curly bracket, key, and you can have as many spaces as you want in between. We have already taken that fact into consideration. So whenever a program encounters this kind of pattern, it will replace it with the value that's mentioned over here in the template string. So once all of that is done, we take this template and set it to text. Then we have 200 OK and everything works fine. Now the next question you might have is, how is this template engine even useful? Right? It feels as if it's not at all useful. And the reason template engines are generally used is that it helps developers create templates for web pages. As the name suggests, you can use this template engines to have static template files in your application, and if you want to change something, you can replace those variables in the file with actual values at runtime. So I'm not statically saying that the name is Rivan. Instead, I can change it anytime I want at runtime using template engine. So this particular file is not hard-coded to say hello Rivan. Instead, it's hard-coded to say whatever variable value you get, just put in over here. So this transforms a particular template we have into an HTML file that can be well perceived by the user using the web page. So this is a very simple demonstration of how you can add support for template engines in your application. Now, along with HTML, you can also add support for pug files for template engines. If you want to know how to add support for that, let me know in the comment section below and I can help you out. So this is it for the video. Thanks for watching and I'll see you in the next video.